Okay, so just as a quick little review of how to use the graph, like number 3, it says what is the solubility of sodium chloride in 100 grams of water at 90 degrees Celsius. Again, 100 grams of water just identifies the graph, so that's extra information. And then NaCl, I'm going to find that line, which is right here. And then at 90 degrees Celsius, that is 40 grams of NaCl. Just as a little side note, number 1, you actually do have to use the graph on page 54 because it goes off the graph. You can see KNO3 is right here, and it's asking you for 80 degrees Celsius, which is here. So they don't actually meet on this graph, but the one in your book on page 54 does go higher. So you will need to use the one in your book for number 1. But for all the rest of them on that whole page, you can use this graph. I'll do one more as like a little reminder example. It says I'll do like 7. How much KCl will dissolve at 90 degrees Celsius, then at 20 degrees Celsius? So here is KCl. And at 20 degrees Celsius, we dissolve about 30. So at 20 degrees Celsius, we dissolve 30 grams. And at 90 degrees Celsius, we dissolve, I would say, about 2 grams. So that's an estimation. So when you do this problem, you might estimate it a little differently than me. So if we're off by 1 or 2, that's okay. It says how much KCl will dissolve at 90 degrees, then at how much more. So we're not looking for a total. It'll dissolve 52 grams, but how much more is that? So I'm going to subtract those, and that's going to give me 22 grams of KCl more. Okay, so keep working your way through that. I'm going to move on to the C2 example. So this is solubility concentration. Here we do have to do a little bit of math. So there is a formula that goes with this when you're looking for concentration. It might also say percent. It might say like percent concentration. That's the same thing as solution concentration. It's the same. The formula you're using is solute over solution. So the solution, just as like a side note, solution is solute plus solvent. Water is usually the solvent, and then something's usually being dissolved in it as the solute. So when I do this first problem, number 1, it says a solution of seawater contains 3 grams of salt in 97 grams of water. So because the salt is going into the water, the salt is the solute. So that's 3 grams of my solute, which is the first part of the equation, right? 3 grams of solute divided by my solution. Water is not the solution. Salt in water is the solution. So this whole thing is the solution. So 97 plus 3 is 100 grams. And then it says what is the percent concentration? So in order to get a percent, we need to multiply by 100. I guess that's technically part of the formula. You need to multiply by 100 just to make it into a percent. So that would give me 3%. So I would do 3 divided by 100 times 100 gives me 3%. So if I was going to do that again for like number 2, it says what is the concentration of sugar water solution that has 10 grams of sugar in 40 grams of water. So again, grams of sugar in 40 grams of water. That makes my grams the solute, and then my solution is the whole thing, right? It's the salt plus the water, so that's 50 grams of solution. And then, of course, times 100 to make it a percent, which gives me 20%. So that's how you're solving the problems for solution concentration or percent concentration.